All right, example 6. It says add and simplify. It's got a big add sign in the middle here, and these are two fractions, and you've got trig junk on all numerators and all denominators. And in order to add fractions, you've got to get the same bottom. So for instance, let's just say if I threw like a random, like a middle school add the fractions problem, I got 3/5 plus 4/6, like that. I can't add them together. It doesn't make 7/30ths or 7/11ths or anything like that. You can't add them. You just can't do it until you get the bottoms the same. And the way you get the bottoms the same is go, hey, look, I got to make both these bottoms 30. You multiply this one, take that denominator there and put it here and here. You can multiply them. And then take that denominator and put it here and here. Like that. And so this problem that had nice small numbers all of a sudden became 18/30ths plus 20/30ths. And then you add them up and you got, what, 38/30ths? I guess that would reduce to 19/15ths. Yeah, so that's how it works. But we got to do that same thing. We're going to do it with trig. Same thought, though. All right, you got to get your bottoms the same. This is going to be miserable. Get used to it, though. You got to take this bottom here, this sine u. And I'm going to have to put it here and here. Do it in a different color, or maybe put a little slight angle to it so you know you're multiplying sine u, or sine theta. That might not look like it, but it is. Oh, and to make sure that you understand the bottom, I put a parenthesis around it. You're going to have to distribute that down bottom. And then you take this bottom, and I'm going to parenthesis, it's going to be 1 plus cosine u, and 1 plus cosine, what did I say, u? Thetas. So take this sine theta, and then you write it here and here, sine theta, sine theta. Take this bottom and write it here, here. That'll definitely be one way you can get the bottoms the same. All right, sine theta and sine theta makes sine squared theta over, for now, I'm not going to distribute in here. Just for now, I'm going to write it as just sine theta and then 1 plus cosine theta. I'm just going to leave it like that for now. If I need to later, I'll mesh it together by distributing. Up top, I will go ahead up top and I'll distribute. This will become cosine theta and cosine squared theta. Cosine theta, cosine squared theta. And then down bottom, I'll just leave it separate for now, but it is still going to be sine theta and that thing. So you should see that the two fractions are now bigger and uglier, but the bottoms are the same. And that's the point, to get the bottoms the same. Now that the bottoms are the same, we can just add our tops, and then the bottom will be, so then sometimes I draw this arrow like this. These two fractions are going to mesh into one fraction with a bottom of sine theta, parenthesis 1 plus cosine theta. I don't know why I put a square there. That was incorrect. Yeah. And then the top is going to be sine theta plus cosine squared theta. Pretty easy to do if that's a plus sign. If it was a minus sign, you'd have to go and distribute it to all the pieces. Sine squared theta plus cosine theta plus cosine squared theta. All right, looks all good. But one thing you should notice, I'll find some spare paper here, is up top you have sine squared theta plus cosine squared theta. You could easily, anytime you're adding three things, you can easily rearrange the order that you add them. So I'm going to swap these two right here. I'm going to swap the cosines there. And I'm going to make this say sine squared theta plus cosine squared theta plus cosine theta over just the bottom, just copying it. All right, so then see how I made that change there. That turned into that. I'm going to bring this up to the top. I didn't really do anything other than rearrange the top two pieces, but I did it for a reason. Up top, and this is perfect. This is going to be weird because you got 3 pieces up there, but the first 2 pieces say sine squared theta plus cosine squared theta. And again, that's got to start sounding familiar. Whenever you see sine squared theta plus cosine squared theta, it can be replaced. You can pull those 2 pieces out and replace it with a 1. Sine squared theta plus cosine squared theta makes 1. So what I've got circled there, sine squared theta plus cosine squared theta, I'm going to take this and I'm going to replace it with a 1. So this ends up being 1, and then I still have that, plus cosine theta over the bottom, which is sine theta, and then I have 1 plus cosine theta. Now here's a little bit of how algebra works. That top is a binomial, and I can actually parenthesize it just so you can see. Anytime you have the same thing on top and bottom, you have the same binomial here in a parenthesis, same binomial there in a parenthesis, they can cross out. They have to be identical binomials for them to do that. And then you just leave a 1 up top, and we end up with 1 over sine theta. And if you've seen the previous examples, you know that that's not a stopping spot. 1 over sine theta should, as I zoom in here, just looking at the top of my identity sheet, heck, anytime you see a 1 over a sine, turn it into a CSC. 1 over sine is the same as cosecant. I think it's marked on my shirt with this Sharpie. So that's awesome. CSC theta. And Sharpie shirt somewhere in here. All right, and that's it. That's as simple as it gets.